Hello. Today I'm going to be talking about the MCAT equation and also the Q equals negative Q equation. And so here is the MCAT equation. It is Q equals mc delta T, and I will go on and explain each variable separately. So Q. Q is the thermal energy, and the units for thermal energy are joules or kilojoules. And there's three different types of thermal energy. There's exothermic, there's endothermic, and there's isothermic. Exothermic is when energy is being released. Endothermic is when thermal energy is being gained, and isothermic is when the thermal energy being released and gained is equal. Next is mass. It's pretty simple. Mass is or M is mass. The units for mass are grams and occasionally kilograms. C is specific heat, and to define specific heat would be the amount of energy required to change the temperature of 1 degree Celsius for a 1 gram sample of a substance, and that is in the units of joules per grams degree Celsius, or occasionally kelvins. Delta T is the change in temperature, which is also represented as TF minus TI, and the units for that are in degrees Celsius or kelvins. So here's a practice problem. How much energy is required to warm up 1,000 grams of H2O from 25 degrees Celsius to 99 degrees Celsius? And also, as you can see, the C of H2O is given, which is 4.184 joules per grams degree Celsius. So now here's how you do it. You're going to want to make, first you want to make a variable list, and see my M is 1,000 grams, my C is 4.184 joules per grams degree Celsius, and my delta T is my final minus the initial, which is 74 grams degree Celsius, or 74 degrees Celsius, excuse me, and then we are solving for Q in this equation, and so all you really have to do is plug in the numbers for where the variables are in the equation. So on the top is the equation, which is Q equals 1,000 grams times 4.184 joules per grams degree Celsius times 74 degrees Celsius. And so the next line is where just all the numbers are plugged in, which is 309,616 joules. But just to make that number easier to work with, at the bottom I have it in kilojoules, which is 309.6 kilojoules. And that's an example of the MCAT equation. Now, next we'll be getting into Q equals negative Q. And I define Q equals negative Q as an application of the MCAT equation used when you are given information from two different elements and need the information from both elements to solve the problem. And so, here's an example of that. It's a long problem. If a 146 gram iron bolt is heated to 557 degrees Celsius and put into a calorimeter containing 85.8 grams of water and the temperature goes up to 97.4 degrees Celsius, what is the initial temp of the water? And so a good way to set this up is to make a variable list for each element so that everything's nice and organized. So you see I have the M, C, and TF of H2O because the question's asking for the TI of H2O, and I have the MC and delta T of iron. And so now we're going to set the Q equals negative Q equation. So all you do is on one side I have the Fe, on the other side I have the H2O. So on the left is 146 grams times 0.444, because that joules per grams degree Celsius, and that's the specific heat which was given for iron, and then times negative 479.6 degrees Celsius, which was the delta T. And that's equal to, remember we have to have the negative, and don't forget the negative for the MC delta T for the water, which is equal to negative 85.8 grams times 4.184 joules per grams degree Celsius times 97.4 degrees Celsius minus Ti. And sorry, I couldn't fit that last part on the same line. And so, simplified, that's negative 31,089 joules equals negative 358.9 joules per grams degrees Celsius times 97.4 degrees Celsius minus Ti. And so you're going to divide both sides by negative 358.9 joules over degrees Celsius, because you see the grams cancel out. And also by dividing that, the joules will cancel out. So all we have left is 86.6 degrees Celsius equals 97.4 degrees Celsius minus Ti. So you just add, you subtract the 97.4 degrees Celsius from both sides, and now you have a negative temperature equals negative Ti. All you have to do is multiply that by negative 1 to make them both positive. So the Ti of H2O will be 10.8 degrees, or was 10.8 degrees Celsius. And you know your answer is most likely right because when you do the problem, the units you don't want will cancel out once everything's multiplied and divided. So if you end up with degrees Celsius, if there was no calculator error, you will be right. And thank you.